Don't go so close to this. There's R2. Oh, well, I guess I won't have to worry about him anymore. So here's an example. Find the surface area of the surface, and this is a function with a saddle point, above the region R, and R is a circle where x squared plus y squared is less than or equal to 1. And so I can even show you a graph of that. So but I'll do that in a little bit. Fx, partial derivative with respect to x, of course 2x, partial derivative with respect to y, negative 2y. When we square all that and put it into the radical, it's kind of nice. Our region R, this semicircle, y limits from negative square root of 1 minus x squared to positive square root of 1 minus x squared, x going from negative 1 to 1. Now I don't know if you can see, that would describe it, but that, ladies and gentlemen, is a bear. That's a nasty one. But we wouldn't want to try to integrate like this with respect to y. Oh god, like some terrible trig function. Oh, something like probably let y equal square root of 1 plus 4x squared times tangent of x. I wouldn't even want to think of what dy would be if I made a substitution. So let's not. So let's do it the easy way. Let's switch this all over to polar coordinates, and that will make things wonderful. So replacing x squared plus y squared with r squared, there we have our new integrand, which is nice. And our dA, r dr d theta, if I integrate with respect to r first, then that means my r limits will go from 0 to 1 like a good circle, and my theta limits from 0 to 2 pi like a good circle. And so this will describe our area that we're finding. So if we make the u substitution, let u equal 1 plus 4r squared, of course du is 8r dr, so therefore we can switch our limits of integration around. If u equals 1 plus r squared and r is 0, then u would be 1. If u equals 1 plus 4r squared and r is 1, then u would be 5. And our limits 0 to 2 pi remain the same, but we wind up then integrating 1/8 square root of u du d theta. Integrating first with respect to u, that's just 2/3 u to the 3 halves, and 2/3 of 1/8 is 2/24 or 1/12 times u to the 3 halves, u going from 1 to 5. And so we've got this phenomenal number here, 1/12 of 5 square roots of 5 minus 1. That's putting in the 1, obviously u to the 3 halves is 1. Putting in 5, u to the 5/3, u to the 3 halves when u is 5 is 5 to the 3 halves, which is 5 square roots of 5. So I think you can see where that comes from. And then d theta, this is just a constant. All this is just a constant, so it's just that times d theta. Theta going from 0 to 2 pi. So the 1/12 times 2 pi gives us pi over 6 times this number. What did we actually find? I got a picture. If you can see this graph, this obviously is a saddle point, and I'm looking down at the xy plane, and the region R would be a circle right here of radius 1. So this number that we found down here, where was it? This number, pi over 6 times 5 square roots of 5 minus 1, is the area over the circle, the unit circle, and on this surface.